Hello and welcome again to another Physical Sciences 3 lecture. So last time we looked at atomic number and mass number of an atom, and now we're looking at elements. So an element is a substance which contains atoms all with the same atomic number. So it is the same number of protons in the nucleus. Each element is uniquely identified by its number of protons. The chemical properties of an atom are determined by its atomic number. So that is the number of protons that determines the chemical properties. Atoms can have any number of protons from 1 to over 100. And remember that the atomic number is Z. Some examples of elements are oxygen, sodium, uranium, gold, copper. Okay, and yeah, so there's many more examples of elements. Now, an isotope. An isotope is defined as each of two or more forms of the same element, so they contain the same number of protons, but different numbers of neutrons in their nuclei. Okay, similarities between isotopes. Different isotopes of an element have the same number of protons, okay? Different isotopes of an element have the same chemical properties, because they're defined by the number of protons, or determined by the number of protons. Differences are they have a different number of neutrons, and different isotopes of an element therefore have different mass numbers. Okay, A is different. So up here we had Z was the same, so we have different numbers of A. And it leads to difference in physical properties. So the chemical properties between isotopes are the same, but their physical properties are different. So we have some examples of isotopes for different elements. So here we have hydrogen. So it has one proton. So all of these have one proton, but we're going up in the mass number. Okay, so Z is equal to 1 for all of these, but the mass number A is increasing each time. Here we have helium, which again, remember, 2 protons. So the red represents the protons, the red pluses, the protons, and then the zeros are the neutral neutrons. And then lithium as well. We have 6, so lithium 6 has 3 protons and 3 neutrons. Lithium 7 has 3 protons but 4 neutrons. Okay, so we're changing the neutrons each time for the isotopes. And we'll have a look at an example here. So, example, hydrogen, atomic number 1 occurs in 3 isotopic forms. Complete the following table. So, normal hydrogen, in quotation marks, we have an atomic number of 1. Okay, number of neutrons is 0. Okay, because if you go 1 minus, remember N is equal to Z minus A, and A is equal to Z plus N. Okay, and we have 1 there. Okay, so I probably should have written in A first. So we can always write in Z and A because we know them first. So let's do that first. So this time again, the bottom number, the smaller number is the Z. The larger number is the 2 up the top. So that's the atomic number. And so 2 minus 1 is 1. Now finally, tritium, which is another isotope of hydrogen. We have 1, and then 3, and then we have 2 neutrons. So what's the important thing about isotopes? So isotopes, some isotopes can be radioactive depending on the number of neutrons. So you can make an atom unstable, and then so nuclear radiation is often because we have an unstable nucleus. So we might need to emit particles from that nucleus in order for the atom to become stable. And we'll talk about that a lot more in this course as well. Now, we need a way of identifying isotopes, and that's done with mass spectrometry. And we might talk about that in more detail in the next video.